Hello, this is a demonstration of the C 4.5 algorithm and interface that we developed for the data management project. Let's look at the source code first. So there are two main structures at play here. One is this C 4.5 node, which can hold other nodes of its type, right there in the children. It can possibly have a comparison value for when you're traversing the tree trying to get a classification. And for each record, you compare it using this node comparison. And it could be one of these. And you'll compare it to this comparison value, as we see down here. Depending on this type, we return this Boolean value or this Boolean value. And that's the decision that that node returns. Or rather, that determines if we should go to this node or not. It also keeps track of which attribute is being compared at this node. It keeps track of its parent so that we can traverse up the tree if we need to. And lastly, it has a reference to a C tree, which itself also is a container of nodes, and it keeps track of just the root. It has a list of decision attributes, which is each column of the data set, which has a name, a type, which is either discrete or continuous, and a range, which is just a minimum and a maximum value that we use elsewhere. I've defined a bunch of utility types, some helper functions such as stuff like getting the mode or the split information or the entropy of a given array of values. And this is the whole class to run the algorithm. We do recursive calls to this split function, and then as for what I ran the algorithm on, I decided to use a subset of all the class attributes. Since there were 33, it really didn't perform well at all. It got like a very high error rate when I tried it on all 33 of possible class attributes, which is the crime type. So instead I narrowed it down to a list of about 8 right here. And I wanted to see if there was any correlation between these attributes that aren't commented out, the month, the time of the hour, the location description, and then the latitude and longitude in terms of the locations. So let's give this a run. It starts reading in the data. Those are the attributes that it's found. And it starts splitting nodes. We'll just wait for it to finish. It doesn't take long. Unfortunately, I haven't perfected the algorithm yet, and it also just goes to show that perhaps this data set isn't quite suited to this sort of classification. However, I believe that we could get lower error rates. My record low for is 48% error rate, which is still horrible, but I believe that with pruning, we could get that down to maybe 30% error rate. However, we didn't have enough time to implement that. So here is the user interface for testing a single data point. Let's say the month is 6 June. The hour, let's say it's 4 in the morning. Location description, we'll look at what we have here. It could be any one of these. Let's choose apartment. Latitude, Chicago is around 41.8 latitude, so and it predicts a class of battery, but again, high error rate, so it's probably wrong. As for what I did for this error level, I took 85% of the entire set and used it as a training set, and then the rest of it I used as a testing set once I was done training it. Thus, we see here we get 85% of the records. We randomize them because they're actually in order in the in here by date. So we got to randomize them a little bit, and then we split them at the index that we found. And that's the user interface code. Yeah, that's it. Thank you for listening. Bye.